Unit 10, Lesson 1 on equations of circles. So this is our first lesson for our new unit. Our objectives today are to write the equation of a circle given a center and a radius. Given the center and a point on the circle, write the equation, and also write the equation if we are given the endpoints of the diameter. So first things first, the circle is the set of all points equidistant from a given point. It's a terrible circle. Right? And the given point is your center. A radius is the distance from the center to any point on the edge of the circle. And the diameter is a segment that starts at one point, passes through the center, and goes to the other edge of the circle. And we know that the diameter is 2 times r, or the radius is 1/2 of the diameter. So r, and the entire segment that passes through the center is the diameter. And we have a semicircle, which is created by a diameter, which is half the circle. So we can write the equation of a circle if we know the radius and the center. The center we denote with h, k. And xy is a point on the circle. So the distance between the center and the point on the circle is our radius. And so we can use Pythagorean theorem to find the distance between the radius and the point. All right, so if we take the difference between the x values, that's here, the distance between your y values, that's here. And so you see this form right here to get the radius, where we would take the square root of both sides after we substitute in to get the radius. So we would take the square root here, and again that gives us this form. This is really what we're substituting into right here. So this is, you have to remember this is not on the reference sheet. So we're going to do some examples where we substitute in our center and our radius into the given format. Again, not on your reference sheet, so you have to remember this. All right, so we have an h and a k, and we have a radius, because this is our center. So whenever we substitute in, we take the opposite sign of whatever we have. So since this is +3, when we substitute in, it's going to be a -3. Since this is a +2 on the y, when we substitute in, it's going to be negative. And this always equals radius squared. 5 squared is 25. So for number 2, we take the opposite of what we see. Since it's a -4, that will be a +4. We would have y minus 0. That's going to just leave y. So y squared equals the radius squared. 7 squared is 49. Same thing for number 3. We're going to substitute in the x. So since it's a +3, we'll have a -3. We're going to substitute in the k for y. So since we see a -5, it's going to be a +5. Again, all these quantities are squared, and it equals the radius squared. 6 times 6 is 36. So we're going to do the same thing for 4, 5, and 6. If you want to pause the video and try them on your own, you can. So since x is negative, we're going to have a +2, the opposite sign. Always plus in between. Y minus 7, opposite of a +7. And this equals the radius squared. 3 squared is 9. Same thing for number 5. Opposite of what we see for x. So since it's a -1, we have a positive. Opposite of what we see for y, so y +8, because it's a -8 in the coordinate, and 8 times 8 is 64. Our last example, we'll have x minus 0, well that's just x squared, plus y minus 2 squared equals our radius squared. 9 squared is 81. So if we're given the center and the radius, we can substitute into our form and get the equation for a circle.